Okay, go ahead. You were going to show me frame sizes.
Yeah, but
On
you
your
need to
screen?
stop sharing your screen first.
Okay.
Okay, so
I wish it didn't have to have more space at the ends. The space that has above and below is fine, but the space it has at the ends is wrong.
okay, I see. Okay, I'll fix it then.
Okay. That's looking nice though. Okay, great. Okay. All right. So the thing I want to achieve here, things I want to achieve. So Max needs to go on working on the that. So right now we believe in SW init2, if I run this, that, okay, so I can run this and this should work, right? Okay. Can even run that. That, by the way, is such an ugly dialogue. I hope that's part of the dialogue that's getting dialogues that are getting fixed.
Yep. So you also sent an email saying you discussed hypergraphs in LCC.
Yes.
What was the discussion about?
It was about how hyperedges. It was discussing whether the current design for graph was going to extend to hypergraphs, and there was a bunch of discussion about how we represent a hyperedge.
Okay.
So I think the main conclusion is there's nothing wrong with, we should be able to use most of the graph functions should work fine on hypergraphs. I mean, they have to be extended, but the syntax of them will work fine. Okay, so I don't think we need a separate meeting about hypergraph right now.
Okay.
But I think in the longer term, and I don't think it's urgent right now, but in the longer term, probably Max would end up putting in a bunch of these hypergraph things as we need them, right? But I think what we're going to do is we still have to decide, are we going to have a hypergraph wrapper, or are we going to have hypergraph distance and things like that? Max, do you have a comment on this? I mean, I think I would much prefer to have a hypergraph wrapper.
Yes, I agree.
And then basically have up values. And some of the up values, I mean, if we have, let's see, where do we have the hypergraph wrapper? I think we actually have a I think things like, vertex list of the hypergraph wrapper I mean, we'll probably just have a bunch of definitions like this. Whatever it is, right? Do you agree?
Yeah.
And hopefully most of those will be rather straightforward. Now, the one thing that came up today was this business about the symmetry of the hyperedges. Did you have a thought about that? I mean,
yes, so apparently for any finite group, there is a graph that has this group as a automorphism. So I think we can actually use graphs for symmetries.
Okay. Okay, so in other words then, so this one, okay. But now, how would we carry that around? I mean, in the hypergraph, are we carrying that around as a second argument or something?
Yes, so it's...
If it's a default.
Let's see. Tricky thing with defaults. Well, okay. Assuming all hyperedges are the same size.
No, we cannot assume that. I don't think we can use this default. I think what we got to do is, look, there are hypergraphs like the ones we're considering, which are ordered hypergraphs, right?
Yeah.
And so in that case, what we would have is something like hypergraph. I mean, the default.
Well, for defaults, for strings, we can have defaults which would work for all age sizes.
Sure. So otherwise,
yeah.
Okay, so here, look, let's, so this is ordered, right? And so then in other cases, what we could imagine is something where we go, where we have graphs for sizes, for particular sizes. You know?
Yes, we can.
I mean, as a default, but otherwise, the general case is hyperedge of whatever, and then a graph here, right? And now, what's the difference? So I think Charles was asking the question, given that we have, what's the difference between the pure graph and, you know, in other words, why do we even need to give the nodes here? Because they're in the graph. Well, I see. A reason is, here's a reason. These are named nodes. This graph can be anything we want. But we have to be able to say, yes, 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 yes. Okay, so look. So the graph, nodes have whatever names they have in the hypergraph. In the, what are we going to call it? The edge graph. The nodes are just 1, 2, 3, etc., indexing into the list of hyperedge nodes.
Right.
So, for example, complete graph of, you know, the case of an unordered hypergraph is complete graph of 3, right? No. Yes, that's right. Yeah. So unordered corresponds to complete graph of n. Okay, I think this is fairly elegant. So the only thing which is a little icky is the decision that a hypergraph by default would be an ordered hypergraph. So I don't think it's totally stupid.
It's just preserving the structure of lists.
That's true. That's true. Good evening, Jonathan.
Oh, hi.
By the way, I should we have a philosophy minute?
Oh, did you see my email?
I did see your email. I basically agree with that.
Okay.
I mean, what I realized is I mean, okay, so this whole argument about whether, I thought I had written a lot more about this question about whether there is an absolute sense of the simplicity of the rules independent of what we as humans consider simple. And the argument that, of course, it's simple to us because we live in this universe, I thought that I had done more to debunk that argument. But, you know, that argument, there's a flip side of that argument. Let's say we succeed. You know, it's obviously non-trivial to find the rules for the universe, even though we live in the universe, right? It's non-trivial in the sense that if we find them, you know, it's like people have been looking for them for a few hundred years. So it's not like they were totally trivial, right? But in a sense, if we find them and they are simple, then one version of what that means is it is a sign of the humility that we should have about ways of thinking about things in the following sense. Because we can't even imagine if we've built something, hypergraphs, whatever it is, right? We've built something where the rules for our universe turned out to be simple. Imagine all those other possible universes where we can't even imagine how they would work.
Right.
And arguably, if it turns out hypergraphs are the winning ticket, we build those because of things that work in a certain way in our universe, even though it's obviously non-trivial for us to get there.
Right.
But,
right.
And with respect to your thing about yes, I agree with your thing about considering things other than Turing machines. It's like the big question is, can we construct the things in our universe? That's the relevant question for the the Church-Turing thesis is.
Right.
I mean, that's the obvious question, and
I think it's a statement of physics, more than it is a statement about something.
Absolutely.
Abstract. Yep.
Absolutely. Yes, absolutely. The Church-Turing thesis is a statement about physics.
Right.
No question. I say that with considerable clarity in the book, by the way.
Mm-hmm.
I even make a different statement, which is, it could even be the case that physics is continuous, but we are unable to prepare things which use that continuity.
Right.
Just like it could be the case that in your observerscopic theory of quantum mechanics, as in not microscopic, not macroscopic, but observer sized, so to speak, where the size of the observer defines the equivalences. Where was I going with that? I lost the train of thought. Anyway, I still am not completely convinced that there isn't. I mean, to me, it seems like, it's like, is cosmograph complexity absolute or not? Well, the answer is it's absolute up to an arbitrary size compiler.
Right. You can always modify things by a constant, by just writing a compiler for some different model.
But the constant maybe the difference between having simple rules and having incredibly complicated rules.
Right.
And it is humbling to think that, imagine a quite different universe. Would we end up coming up with a quite different set of things to even consider for how it's set up?
Right.
And things that, even though obviously what we're doing is not exactly simple to understand, it suggests the possibility that there are things that are even much further away from our ability to understand.
Right. Okay. It sounds like our views are closer than I initially thought. I guess my only potential point of disagreement was about exactly what the trade-off is between algorithmic and computational complexity. In other words, the fact that these rules were non-trivial to find and that it's taken a long time for us to get to the point where we might be able to find them, how much of that is due to intrinsic algorithmic complexity of the rules and how much of it is due to the computational complexity of their implications?
Oh, well, I mean, we don't know yet.
Right.
I mean, if the rules are algorithmically simple, then it's all computational reducibility.
Right.
That's the big issue.
Which I don't know. My argument was, I think that kind of has to be the case if the strong Church-Turing thesis is right.
Why? I don't think that's true. I mean, the fact, you and Aquinas both argue that, the rules of the universe are simple, which is to some extent obviously true, given what we observe. But I don't understand why the rules of the universe have to be simple. I mean, are you saying that if the rules of the universe are sufficiently complicated, you can use them as an oracle?
Right. I mean, in a sense, I'm saying that the model of if you have a universe, that universe is itself a kind of model of computation, and that model of computation, I think, puts upper bounds on the maximum algorithmic complexity of its own minimal description.
Look, the fact is, it's like you can weigh the sort of algorithmic complexity of some axiom system. You can weigh the algorithmic complexity of the universe, and there's a certain amount of mining you can do. There's a certain amount of true randomness in the universe, which is equal to its algorithmic complexity.
Right.
right? And so, although that's a slippery slope because of the slippery thing, because of the language in which you describe it, but so the question is, how much randomness mining do we get to do? How random is the universe? If the universe has very low algorithmic complexity, it has very little intrinsic randomness, and everything that's in it has to come from computational irreducibility, basically.
Mm-hmm.
But I'm not sure we're disagreeing about anything here. I mean,
No. I don't think so. That's. I thought yesterday we had a bigger disagreement than it turns out we do. So all is
right,
fine.
fair enough. I mean, look, of course we actually have to find the universe. That's
right.
The minor issue. It's just like they say in it's a minor problem of software in the okay. All right, so just with respect to hypergraph, I think then we're agreeing that the specification of the hypergraph, so the default specification will be an ordered hypergraph. And we will have certain other named ones here. I think this case is exotic. And I think in this case, that really we'd be better off just saying hyperedge of edge graph. And the only reason to have an edge graph, I see, the question is there a natural way to give a list of edge graphs? Yeah, actually, this is very easy. You know what? It's very easy, because all we do here, this case here is, graph 1, graph 2.
We can have a list of rules. Pattern goes to graph.
It's not a pattern, because we just want to say, in this case with the default, this is just saying, actually, look, you know what this is saying? I'm sorry, there's a simpler thing to do here. Never mind, look, there's a simpler thing to do. The next thing to do is graph elements connected according to the specified edge graph. Okay, and now the final case here is spec 1, spec 2, ... different specifications, specification type n for hyperedges with n nodes.
So I think instead of that, it would be more useful to have a list of rules where we have patterns that would match edges on the left and graphs on the right. Because then we can have 3 edges of 2 different types, which, for example, have nodes were named in different ways or something.
All right. Well, I mean, these are not incompatible. So then the final thing would be a pattern. Okay, pattern for hyperedges. Sorry, you're saying a pattern.
What do you mean? It patterns goes to graph.
It's a set of rules, right?
Yeah.
It's a set of pat1 goes to well, it's just spec 1. It doesn't have to be a graph. It could just say unordered. Yeah. Right? And then that's patterns for hyperedges. And that will be applied using replace, basically.
Yeah.
I think this is nice. And for the case where all the hyperedges are the same, whatever, then it's just this graph. All right, what I would recommend that we do, given the practicalities, what we have to do is that we start filling in graph properties here. So I mean, like, for example, if we say, assume that this is a naked one of these without, and assume that this pattern here is basically of the form list of a list of lists, basically. Right, then that is not a bunch of hyperedges, it's a bunch of lists. So in that case, for example, this is simply union of flatten of list.
Catenate, not flatten. Because vertices could be lists themselves.
Yes, that is correct. Right, it's that. Simple.
Yeah.
And I mean, you know, and something like, okay, so for example, if we say hypergraph, graph distance of hypergraph of that same pattern, right? Just to get some sense of what's involved here, comma, and then graph distance, I think, just takes two things, right? You know, I wish that this font was better matched. It's just so annoying. I should have brought that up. Sushma, could you possibly take a picture of that and send it into TNU Docs?
Yeah. Ah, wait 1 second. Yep. Okay.
So how would we compute that? And then we're going to get off the subject. I just want to get some sense of what's going to be involved here.
Well, first we need to convert them to normal two edges, which could be done by partitioning to 1. And then we catenate those and just do ordinary graph distance.
But doesn't that... Oh, you say it's just catenate?
Actually, no. That's no, because if we have hyperedge 1 to 3, then graph distance from 1 to 3 is 1, not 2. So instead of catenate to 1, we need to, I don't know how it's called, but it's kind of a triangle complete graph.
Why? Because this is the ordered hypergraph case. I mean, the case that what we want to do...
Because in a hypergraph with a single hyperedge 1 to 3, the distance between 1 and 3 should be 1.
Yes. Yes, I see. So what we want to do is we want to turn that into edges 1, 3, 1, 2, and 1, 3.
Yeah.
But actually also 2, 3. So each one, so let's say we have a thing that says 1, 2, 3, 4. We want to turn that into every pair, not just every pair in sequence, it's every number. It's the tuples. It's this thing, comma 2, isn't it? It's the ordered tuples.
No, because we can't go from 2 to 1. I think it's subsets list 2, assuming it doesn't reorder them.
I'm sure subsets does reorder. Subsequences? No, I don't think that's quite right either. Yeah, that doesn't have AC.
No, it's not a sequence. It's
I know. It's
subsets.
I know, but the problem with subsets is, right, so if I go 4, 3, 2, 1, I predict it's going to give the same subsets. Oh, actually,
Well, it
I'm
does the
wrong.
right thing now, but I mean, we need to make sure it's not going to change.
The elements of the list are in the order returned by sort.
Okay, essentially it's saying that it's undefined, those original elements are not sorted.
Yeah, I think we have to write something that does this. Okay, but in any case, it's clear roughly how we do this, right? And so, for example, your stuff for dimension and so on, let's just look at that for a second. Where is your thing for dimension?
It's in
code development?
I don't think so. No, it's probably in working material or in results. Yeah, I think it's in results.
Which we should get rid of, by the way. We should put this in working material.
I mean, we can do it right now.
What is this?
So it does BFS on it and collects the sizes as it goes.
Well, that's really nice. But I mean, we can clearly turn, for these purposes, we can turn the hypergraph into a graph. Because this is the same thing as for graph distance, right?
It needs to be efficient. It needs to collect all distances simultaneously.
I understand.
Which is why it does BFS. And we need to have efficient BFS implementation for hypergraphs.
But why not turn the hypergraph into a graph and then do BFS on the resulting graph? So I'm suggesting that there's a subsidiary thing saying distance equivalent graph of hypergraph.
Yeah. Yeah, I think that will work.
And then, now, presumably, what is this multi-generations plot?
See. I think it's the plots that are shown below.
Oh, I see. So we should be able to get this. We should have a function that gets this data out. So what is the right name for the function that gets this data out for a given graph? This is graph ball volumes.
Well, in this case, it's dimensionalities.
Okay.
It's I mean, instead of ball volumes, we should probably say neighborhood sizes to be consistent.
Okay. Is there a neighborhood sizes function for graphs right now?
I thought there was something similar. No, actually, I don't think there is. But there is a neighborhood graph, which is another name for ball.
Mean neighbor degree?
Why mean?
Well, it just says, no, it's down there. It's mean. Okay. Okay, so you're saying that this should be graph neighborhood sizes. Is that right? But it goes over the whole graph, right?
It sounds like neighborhood graph vertex count list.
Yeah, but it's not. You already did the average over the whole graph, didn't you? But we're not going to want that. We're going to want it for a particular list of edges, of nodes, rather. What did you find, by the way, in here? What? You found that this thing has a flat region of dimension about 2. Is that right?
Well, yeah. And it makes it random smoothes dimensions plot, which is is not surprising.
But this guy
This
is
is
a
purely
Sierpinski.
nested one.
It's a Sierpinski, and it has dimension about 1 point whatever the Sierpinski log to the base 3 of 2 is. Log to the base 2 of 3. That's pretty cool. And that has dimension asymptotically 1.
Well, it's just a, you know, a circle.
You know what? This should be part of our usual. Okay, well, we can move that into working things, but this should absolutely be part of our normal. You know, we need a function that does this. Okay, so what should it return? This here is returning averaged over the whole graph, correct?
Yes.
Okay, which
Actually, I think it produces all data is an intermediate step.
well, I don't know what this is. Graph of undirected edge. Oh, wow, it's making the edges undirected, which I don't think is the right thing to do.
Why not?
Because we don't want to go the wrong way down an edge.
Why?
Well, because if we want the causal network, if this was a causal network graph, we sure don't want to go the wrong way down an edge.
But it's not a causal network graph.
It could be. We could run this code on the causal network graph.
But it wouldn't produce anything sensible because dimensionality measures in the causal network have to be done by space-time cones. You have to use geodesics. You can't use balls.
Fair enough. But still, don't you agree that we don't want to go the wrong way down the edges here?
No, I don't agree because I don't think the directedness of edges have anything to do with topology of the thing.
Well, I agree that the topology is determined by what can get from here to there.
I think it's worth dealing with both cases, given that we don't really know how the metric for the manifold is going to limit out.
Yeah.
I think it's worth trying both.
Okay, but so what does this actually return, do you think? Max, what do you think this returns?
It probably returns for each vertex and for each generation the list of dimensions, but I'm not completely sure.
Okay, but so let's assume let's say we call this graph neighborhood sizes. Counts neighborhood sizes.
Wait, vertex counts.
It's not vertex count. It's a neighborhood. It's the number of vertices in the neighborhood. So it's
Yeah, graph neighborhood vertex counts.
It's a mouthful. Well, okay.
Why
All
not
right.
volume?
We certainly have a lot of that here, right? So we've got graph diameter. So you're suggesting graph neighborhood volumes.
That would be my suggestion.
Seems sensible to me.
I mean, it is legitimately a volume measure under the transportation metric.
Okay, so then we believe that the code to do that is what? It's just this thing that's called conveniently volumes.
Probably. We probably need to change it a bit because it clearly uses self-substitution evolution instead of new.
But
Anyway,
this
it might
thing
not
should
work
just
anymore.
take a graph. It shouldn't care how it got the graph. Right?
Yes, good point. Yeah, by this point, it already just uses a graph, so it probably just works.
Oops. Okay. So let's say graph neighborhood volumes of, got your favorite graph, just a complete graph, let's say. What's a good example of a how about a K-ary tree? Okay, that looks extremely convincing to me. Don't you agree?
I think so.
So then what we do to get the mean, well, you've got all kinds of issues to get the mean and things and get the dimension from this, but this is at least giving find the volumes of successively larger neighborhoods around nodes in a graph. Okay, so here, the simplest case is just graph finds the list of neighbors at successive distances. That's the count of neighbors at successive. For each node in graph. And then what we probably want to do.
It's not quite at distances, it's at or below distances. So it's within distances.
Is that right? So if I have a line graph, how do I get a line graph? I would say just table I goes to I plus 1, right?
Isn't there a path graph?
What's it called?
There is path graph.
What does that do?
Path graph of list of vertices. So path graph of range 5, for example.
I see, I see. So this is, so if we wanted it for shells, we would have to do the differences between for these, right?
Yeah.
Also, is there an argument that this should be an association mapping vertices onto these lists?
Yes, I think so, because the vertices might have names.
Right.
Where is the list of? That's a parallel map there, but we want a parallel association map of some kind. Well, actually, this just goes to vertex list, right? So all we have to do is say hash goes to this, right? This function, there's a hash there. Oh, what is this mapping onto? Where does the hash, where does it pick up?
I think that's the hash you selected after graph.
Okay. All right, so in fact, this would just be hash that, and that would be association of this. Good idea. Okay, and then what we have to do finds the counts. Finds the counts for the vertices v sub I. I think that's just for efficiency. And where is that? That's mapping onto the vertex list here. So this would be, well, actually, we have to do here. Sorry, let me just rewrite this here. Okay, cool. So if we just want it for vertices, three and four, there we go. Great. So that was easy. And we obviously have to untangle the hypergraph case. But we also need the dimension estimator, which is your separate thing here. I don't know what the vertex count of graph is.
So it pads them to be the same length for each vertex.
Okay. And then you're trying to get a generation, that plot for successive generations, which is really nice. So where are we going to keep utilities like this that probably don't need to be in the function repository? You know what I'm saying?
Well, I mean, my suggestion would be to just keep it in the package, but you probably wouldn't agree with it.
Well, we got to document it. We got to have something that talks about it somewhere. I mean, this is part of, we're going to have a bunch of sort of research code.
So is it research? I mean, my view is that if the research code is used only once or twice, we could just keep it in the notebook where it's used.
I agree, but I think it's
used
useful.
Many times. We should just as well put it in the package and make it industrial.
Yeah, I know, but I don't know how industrial. I mean, we don't know how much it's going to be used until we've used it. You know what I'm saying?
Right. So we first just keep it wherever it's used, and then if we see it used,
I know, but I
times,
like having it in some place that's. I think there's an intermediate thing there, because I like to have something where, because I will use it for several different studies, but they might only last 2 days, and then we're over that. You know what I'm saying?
I see.
But I mean, we could have it in the function repository, graph dimension estimate. But I mean, then we're going to want these kinds of pictures, right? But I mean, those pictures are obtainable. I mean, there's nothing special about that. I mean, the final graphics to get that picture, I'm not concerned about us having somewhere. I'm just talking about doing whatever you were doing to get the dimension estimate.
Right.
Yeah, by the way, Max, what were you doing to get the dimension estimate?
Oh, there's equations in there.
Yeah, sorry, can you scroll up to the top? Right, and that's what you're using?
Yeah.
In which case, I have reservations about whether we should call this dimension.
Fair enough.
Because it's dimension assuming zero curvature. It's a sort of pseudo dimension, in our modification of GR, in which we treat curvature as being, local modifications in dimension, it's dimension, but it's not dimension in the standard sense. Right?
Fair enough.
We want to take this and the dimension is the leading order term, and the curvature is the subleading term.
Right. So we want to fit this function. So I mean, the issue here is only.
Well, you should be careful fitting it, because dimension might change with scale.
Of course, and it might change across different. Right. And there are many things that might go wrong here.
Yes.
But insofar as it's uniform, I mean, this is the raw data we need, and we've got to combine these things. So for example, look, this one is growing faster, right? Probably it's the root or something. Like if we take these, okay, and we simply say, for this thing here, we say values of that, and we say list plot. Okay, that's showing us the distribution. You know what I'm saying?
Right.
And if we do this for like 100 or something, wow, those dots, there we go. Right, and we could as well. Right, so that's showing us the growth here. Do you think we have a standardized Sierpinski graph, or do we just grow it from this? Well, anyway, okay, we can, but for the Sierpinski graph, we'll see the thing jagging around. I mean, this is basically has a certain growth rate on average. I mean, I think if we, what's a good way to do this? I mean, for every, we could find the mean. How would we make a thing that is a plot of this showing, smooth kernel density estimate type thing, right? That's the, you know what I'm asking? Yeah, I mean, what I'm asking.
Kind of,
What's that?
but I'm not sure how to do that.
Well, okay. So all right, but anyway, let's move. Okay, so we've got this. That's all good. Let's move your dimensionalities into working notebooks now.
I mean, we can probably move all three of them.
Yeah, I know, but let's look at what the others are.
Oh, that's my essay.
And what do we conclude from this again? Can we summarize this essay more simply now?
Well, there were nothing particularly interesting up to a certain size. That's the summary.
Okay, well, okay, so let's rename this Maxime Summer School Project. Just so we have some
Use
idea.
Max now as a default.
Oh, yes, sorry. Okay, I'm not sure that I agree with that. I think Maxime sounds more exotic.
But it's
Exoticity
wrong.
is good.
It at least should have X in there.
Well, okay, I didn't make it up, the transliteration. Who made up the transliteration?
Well, the Russian government, and they didn't give me any choice.
Really?
Yes. And I was very unhappy about it.
When did that happen?
When I was getting at my passport, new version of it.
Someone should add that to the ILD agenda.
What?
Retrofitting Max's name.
What do you mean? You mean in the company directories and things?
No, company directory is already correct.
Okay. All right. So I see. So it's wrong because there isn't an X. Is there not an X in Russian?
No, there is not.
And so they couldn't admit that there was an X, anything better in another language. So they gave you a transliteration that involved. Is that true, or is that? Am I making?
That sounds very much like Russian government.
Okay. All right, let's put that there. Okay. Did this pan out?
Well, not quite, because it tries to embed manifold into, in the Euclidean one, but it should estimate metric as well. I mean, it should fit metric as well, so it doesn't quite work.
Do you think it can be made to work?
Well, not in straightforward way. I don't think we can use that code anymore for that.
Okay. Well, let's at least put that in. All right, results is now history. Hey, Sushma, what's the status of getting the preview thumbnails for the working material?
Preview thumbnails. There hasn't been much progress yet. I mean, it's mostly with John Fultz and Andre.
If we're going to do this, let's put that in that folder. Makes sense. Okay. All right, let's go back. Okay. The thing I wanted to make sure we did is finish the multi-way. Okay, there's multi-way system code. Max is working on rule plot for hypergraphs. Okay. But now, so I think we should all look at this multi-way system code because you've all been involved in it. So let's see if we can unscramble it once and for all. We're very close. And then the other thing I want to achieve is just getting these functions ready for the function repository. And by the way, we need to add graph neighborhood volumes to our list of down here, we want to have something that says graph analysis. And one of the things we have there is graph neighborhood. Volumes. Okay. All right, so obviously Jonathan's things here will have to be modified once we have the hypergraph wrapper.
Right. I'm also wondering if I should incorporate additional functions for the cyclic case and things like that, or the case for arbitrary symmetry groups.
Well, eventually, yes, but not. I think that is completely unurgent.
Okay.
In the same sense in which it's not worth studying models of computation that don't follow what our universe does. I mean, we haven't yet killed the ordered hypergraphs. Okay.
Actually, speaking of which, did you see the email I sent about Ed's canonicalizer?
We were we were either talking about that. Yeah, so you've concluded that his canonicalizer is sort of okay.
I mean, from the point of view, yeah, there are no longer obvious cases where it fails.
Okay, well, have we put that in a function repository entry?
I mean, that's easy to do.
But
yes.
do we have the design for the function repository entry?
Yeah, we talked about giving a rule, and also it should be extended to list, which is probably easy to do as well.
Here it is.
Yeah. This is the old canonicalizer, though. So
okay, so let's just put
yeah.
the new one in right now, because then we can use it. I mean, where is the new one? So.
Oh, I forgot to add it in the. It's in the email, but I forgot to add it in Dropbox.
Email from Ed.
Yeah. November 5th, 3:15 Eastern.
What's rule signature random? What's all this stuff here?
Those are all the things he had worked on for this project.
Okay,
basically.
but is this
Yeah.
which part is the canonicalizer?
The canon rule is the canonicalizer. So the 4 in
And
yeah.
what's put in standard order? Do we need all of those things?
Yes. Yes.
Okay. And we should put Ed's thing into working notebooks.
Yeah, I'll do that.
Okay. So we can get rid of semi-canon.
Yes.
There are no semi-canons anymore.
Oh.
Only canons.
I don't think we need the tupling one either.
Wait a minute.
The-
There are 2 definitions of canon rule here.
Yes.
Oh, one is with S there. I do love the way that Ed always gives us homework, 100% of the time. Okay, we don't need that.
But also, my reason for the email was I thought your justification for using heuristics in Ed's case was that it was faster than doing, finding canonical rules by isomorphism testing.
Okay.
Or am I misunderstanding?
I was also actually doing the examples that you sent, Jonathan, and I didn't like the absolute timing for mine when I did it. It was not really that different.
Really?
Yeah.
Even for large hyperedges?
Yeah.
Okay. Then maybe it's something weird about my setup. But I mean, when I tried things, it seemed exponentially slower.
Yeah, I tried all the examples that you sent. I mean, I don't have it in my screen right now.
No.
Yeah.
I believe you. I believe you. Okay, but that's weird.
So can we then set it up so that we have we could have a method option here or a performance goal,
Mm-hmm.
which we think is speed versus quality, unless it isn't. So what the hell is this? What is this? This is ridiculous.
I think that is how he takes breaks.
That is a classic of oh my gosh. Okay, so this rule signature random is his version, I think. And by the way, index subset, he hasn't.
It is submitted to the function repository, but not published yet.
Okay. And what about the pure enumeration? Does he have that now?
He replied to it saying he has a version of it, but calculating the rules with repeated hyperedges is not easy, but he has the one without repeated hyperedges.
Okay.
And I think Max replied saying it is useful to have repeated hyperedges.
Okay. Well, let's at least put in so that we have. I mean, we need clean versions of all of these things,
Yeah.
so that they're submittable and they can always be improved, right?
Yep.
Okay. So do we have a name for the random? I think we do. I think we have random. Okay, so that's my version of that. Does Ed have a different version of that? It appears to be identical. Oh, it's just
That
my
is,
code.
yeah, I think that is what Ed sent.
I think that's my code. I think I wrote that. Well, yeah, I think I wrote that. And trivially, do you think we should, yeah, okay, generates a random Wolfram model rule with the specified signature and S possible symbols. Signature wait a minute, slash out. What does this do? This is nonsense. Oh, maybe this is Ed's code.
That's an interesting identification algorithm you use there.
What?
This is nonsense. It must be Ed's code.
Well, sorry. Okay. Well, so this is at least yeah, because he hasn't this rule signature thing. Look at this crazy thing. How can this possibly be right? Because it's not distinguishing the right-hand side of the rule signature from the left-hand side of the rule signature. You see what I'm saying? I'm sure that flatten is wrong. Well, it probably is okay for integers. If it's a list of rule signatures, then that's basically just a list of Wolfram model rules mapped over each signature, I think. Oh,
Yeah.
except we might have to call the canonicalizer again at the end.
Oh.
Yeah, we don't want to call the canonicalizer in the middle. We want to call the canonicalizer once we've got the final thing.
But I don't think the canonicalizer currently supports list of rules. So
But then it's wrong.
yeah, I mean, we have to first extend the find canonical Wolfram model and then
Yeah. I mean,
extend
but
to.
he needs to do that because otherwise it's
Yeah.
just wrong.
Yep.
Does everybody agree it needs to canonicalize across multiple rules, right?
Yeah.
Because there are two identical rules.
Does the tree need to do anything except deleting identical rules?
Yes, it needs. Doesn't it need to canonicalize?
Okay, there are two things. First, deleting identical rules. The second, it's possible that there might be rules that will never be used. So it
Well,
might
that's a
need to
different
use those as
optimization.
well.
But I'm asking the question: if you relabel the variables, right? Can you do it independently for each rule? I
Yes,
guess
of
you can.
course.
Oh yeah, you can. Okay, I'm confused. It's okay. This is okay. Where each LHS or HS is a list of pairs arity, right? It's a list of pairs of the form count, comma, arity, where the count is the number of hyperedges of specified arity, right? So now here, in principle, the different rules could have different symbol counts, right? Am I correct?
Yes.
So maybe this is not a good way to specify it. What should we do about that? Well, I mean, you can always generate them separately. I mean,
Yeah, I don't think we need to do anything.
okay. Okay. All right. So this this we should save, right?
Yes.
What should we call it? We could call it rule canonicalization. So we remember that it might be crazy. Okay. All right. We should look at the multi-way thing, and we should look at the generator that generates notable rules, and then we can wrap. And then I'm going to go looking for rules, because I think well, let's just check that we have everything we need to do a big hunt. I shouldn't call it a hunt. That's not politically correct in today's world. What do we call it? Harvesting? No, that's not correct either. I don't know. What can we call it? What's that?
Sorry, harvesting seems even darker somehow.
Yes, I think so. It reminds one of Hunger Games.
Right.
So that. Okay, where are we looking here? I need to do SWNet. Okay, so here I can just do that. Oh, for God's sake. This Max is going to fix this real soon, right?
Yes.
That's my rule display stuff, and that's my testing stuff. Okay, hold on. Then we've got other functions. And for that, we have, what functions do we have here that we care about? We have some of Jonathan's functions. And this is all tentative because eventually these will be in the function repository and we won't have to do this. And then all we'll have is a guide page to show us what to do.
Yep.
Right? Magnificent. Okay, what else do we have here in the repository? So hypergraph plot is or is not relevant from the repository. Max?
Well, it's better to use one from the package.
So from here.
Yes. Because that one I will definitely update.
Okay. Okay. So we've also got overlap-free strings and so on. I don't know whether did we commit those to the Oh.
No, I was going to finish those things off, but I've been prioritizing other stuff. But I think you assigned those to me.
Well, I think they're almost finished, so. Although if we actually gave the number of strings there, I mean, if we actually gave the elements, it's like a tuples. What's that N there? Oh, that's the pairing. Okay. Did we list that in our page of in our list of
This function you have.
in this page here?
Yeah, the string. Yep.
Okay. Okay. I mean, it's slightly hokey to use just these ABC, but I think it's kind of okay for our purposes, and we could generalize this by just giving a list instead of a number in that position. Instead of nchars, we could give a list of characters there. I don't know whether this is the right argument order. What do you think? That's the number of strings. That's the maximum length of a string. Is that the maximum length or the...
Yeah, maximum inclusive.
gives overlap-free, gives strings of length up to n, strings of 2 characters, with lengths up to n that do not self-overlap. So
By the way, I'm going to make an argument that the argument order should be the other way around.
I think you're right.
Basis of analogy with tuples.
I think you're right. Which order should it be in? It should be in the characters first, right?
Right. In tuples, you give the alphabet first and then the length second.
Right, but if you only give one number, it's going to be the length.
Right. Right, and it'll assume a binary alphabet.
Okay. And then we give the number of strings that we're dealing with third. Right? And the length should probably not be called n. What should it be called? Well, actually, gives strings of 2 characters with lengths up to n. Okay, so then the next case is k, comma n, gives strings of k characters that do not self-overlap. Then this case is gives, what should that be called? How many strings there are? S. S tuples of strings of k characters do not overlap themselves or each other. Correct? What the hell is that doing? Why is find overlap free? So this is 3, 4. 2, 5, 2. All right. Okay. I mean, this is probably uploadable in some form. Well, the Sushma should look through and figure out whether some of these other ones. Okay. Let's go back to, okay. Again, let's enumerate some more things. So Wolfram model, the documentation, what is the state of its documentation?
Well, I didn't do anything with it yet.
But we had in
Yes, we have documentation, but it has more things in it than I implemented.
which one is the most recent documentation?
Well, I think it's in the code development.
Okay, fine. So then let's put that into the function repository, right? So that we keep it in a consistent pace. Got both that. Okay, so here we've got Wolfram model documentation. Okay, so okay, all right. So this is not bad. But this is actually, we could actually run some examples here now.
Yeah, we can.
Okay, let's look at the other, let me rename this without the word documentation there. Since it actually contains what we need to load it, right?
Well, not yet. But that's the idea.
Okay, the Wolfram model evolution object is a thing, right?
But
Yes.
should it really be? Yeah, so how does it work? Because it doesn't seem like it should be function repository function. Does it?
Why not?
Because it doesn't make, well, it doesn't make any sense without Wolfram model, and it shouldn't be used by the user directly.
So what context would you put it in?
What do you mean?
What context would it go in?
Well, I think it should be in the same context as Wolfram model.
Why not have it be part of the Wolfram model entry?
Can you do that?
I don't know whether you can do that.
I mean, more general problem is there are a lot of these things that are integrated with each other, and it's not clear how they're supposed to work in function repository. That is, if function repository functions loads the package when they're first used, then they are going to conflict with, I mean, there would be a normal function which comes from loading the package, and there will also be function repository objects. I'm not sure how they're supposed to interact with each other.
Look, the function repository thing, It is a wrapper, so you can have sub-functions that go into some weird context, right? But the exposed functions should be function repository functions, I think. I believe that's the only way to do it that isn't going to mess up right now. Sushma, do you know?
Yeah, I mean, that is possible. I was also seeing that there is quaternion, which is just like an object.
How does that work?
So
What context is it in? Let's look.
that was from standard packages, I think.
No, I know, but what context is it in now in the function repository?
There's no context, actually. What do you
Well,
mean?
but it has to be in a context. If it's a symbol, it's in some context. Right?
Hmm.
No, it's a function repository object.
Yeah, but it is just an object.
Yeah, I know. So that's what I'm saying. That's a model for what we should do with Wolfram, with both hypergraph and look. Let's look at the source notebook. Okay.
Yep.
Definition notebook. That's totally weird. How does that work? What's it doing? What the heck is that?
Well, apparently it loads another function repository entry.
Which is not, I don't see that entry, which is kind of surprising.
Well, this looks kind of hacky, but it's obviously doing something here.
So, I mean, I feel like there is no harm in just having a function repository entry, which is the evolution object, and we'll just give the summary blob.
Yeah, I agree. I think that's what we should do. So let's look at how quaternion works. So whatever quaternion is doing, okay, there it is. Okay. And that's the output quaternion. Oh, that's great. That just works. That's really cool. You know, the failure to have these numbers that say how much stuff there is under there is really annoying. And the failure to have these work properly is really annoying. Anyway, why exactly that's, oh, I see, that's 2 to the power of that quaternion. I wonder why that doesn't work. Huh. Well, I wonder why 2 to the power doesn't work. I'm going to send a message about this function. Okay, well, why not do this however quaternion is done, okay? So that we will have that thing in there as a function repository thing, okay? Right, Max?
Yes, I think so.
I mean, the important priority here is that we've got to be able to let other people use it. So we don't want some whole giant fragile, system for this. It's got to be the case that it's just in the function repository and people can load it in. Now, what are you going to do if it's in the cloud right now? We should just say it doesn't work in the cloud, right? We should just test for cloudness and just say it doesn't work. One input. Am I making sense?
Yeah.
unless it's possible to whitelist it in the sandbox, even right now, based on its library link ID. Do you see what I'm asking? Sushma, that would be for you to check into.
Yeah, I don't completely understand, but I understand what is needed.
Okay, so the issue is this. The issue is this, that the Max's thing involves C++ code, right?
Okay.
Which is loaded through library link.
Mm-hmm.
In general, functions in the cloud cannot run arbitrary library link code
Okay.
because
Okay.
of the sandbox. But certain library link modules are excluded from the sandbox if they're known to be safe.
Okay.
Okay, and I don't know what's involved in doing that, whether there's simply a library link ID that you have to put in, which could be added to the sandbox in a cloud release.
By the way, speaking of it being safe, I'm not sure I can necessarily guarantee it, because if it if in other words, if it crashes in some weird way that can be exploited, no, I can't guarantee it's not going to happen.
Yeah, well, I understand, but I think the sandbox, we can look into that, but I think it'll be okay. I mean, it's the
Yeah, we need to be careful so that somebody can just break the entire cloud because of it.
obviously. So
we need to talk to some security people, probably.
yes. Yes. Okay. All right, but this assembly, we really need to get, okay, so what you're telling me is that if I now run, now that I have all this done, you're basically telling me that I should be able to run, okay, so I should be able to just run random Wolfram model rule of, and now I did some enumerations before, so that is,
I don't agree with the statement that it's fragile right now.
What's that?
I don't agree with the statement that it is fragile right now.
But what's fragile?
It takes 3 steps to build, the package.
Oh. Okay, Jonathan has to go. We get on the multi-way system before 3 a.m. I'm sorry, Jonathan.
That's okay.
Can we just take, let's just survey what's there, okay? And then you go, okay? Let's just give us 5 minutes.
Yep.
Okay, because it may be, I'm sorry, I know it's super late for you. I apologize. Oh gosh, where is it? You always know there's trouble if I start talking about random philosophy stuff. Okay, so in here, what the hell is that? What's that?
Ah, you defined graph earlier, and apparently Tony's code does the same.
But that's no good. That's no good. I mean, Tony needs to, okay. Sushma, could you screen capture that and ask Tony to please encapsulate his thing properly?
Yeah. Yep.
Oh, gosh. Okay, so I went on. Okay, I believe I unscrambled most of these. This is various styling, which I'm sure we can handle.
Right.
Okay, this code here, I put back in based on trace states list. Okay, I just reinstated trace states list to make this code work.
Mm-hmm.
But if that code is going to be generalized.
And it uses the new event structure.
No, it does not use the new event structure. It's just using traced. It's just using the old trace states list.
Okay, okay.
So this is just a reinstatement. So the character evolution causal graph, I have no idea what that. And this unmerged graph stuff, I don't know what to do with that. Is that your code? Whose code is that?
It's not mine.
Okay, who knows about the character evolution causal graph? Is that yours, Max's?
Yes, it is.
Okay, and what is it, and is it still needed?
Well, it shows, so okay, so it is graph in terms of characters in strings. So it's string and then character in it, and it shows causal network of those basically.
Okay, but so Jonathan has a causal network that isn't quite right. Is that causal graph only wrong in its self loops, or is it wrong in other stuff as well?
I believe it. Well, on the test cases I tried it on, if I called simple graph on that, it gave, well, it agreed with previous causal networks, but I'm not.
I don't think simple graph is the right thing. I think you
No. I mean, there's a problem. I mean, there's an issue with the algorithm, but that will not be difficult to fix.
Okay, well, could I ask then that okay, so then I'm trying to figure out what to do here. I mean, we could maybe tomorrow. Are you going to have a chance reasonably early tomorrow to look at some of this stuff?
Yeah, I can probably fix most of what's been highlighted here before you do anything tomorrow.
Okay. All right. So then, okay, we might try to put in the thing that inserts Wolfram models in the multi-way system and displays them, which I think I've written the display code here. In fact, maybe I even did this. I think I even did it down here. I think I did it, actually. Oh, no, I know what happened. It just didn't work. Or did it work? Oh, it always gave a single result. It just didn't multi-way itself. You see what I'm saying?
Right.
And if I say,
Which is correct, isn't it, for this particular case?
I don't know. Oh, look, those are little tiny, tiny, tiny universes there. I mean, that's some. God, that's hard to understand. And also the arrows are in the wrong place and things. I don't know why those arrows are wrong. It thinks
They
those
just
things are up there.
disappeared.
Yeah, it thinks those things are a lot bigger. But is that model just not one that does anything interesting? I mean, is there a trivial Wolfram model that will multi-way itself? I think I might have to put it in the list there. Oh, for God's sake. Okay. What on earth is that? Okay, so this needs, I mean, so I'll leave this broken, okay, Jonathan? So there's another thing there that's needed.
Sure. I mean, I think that's your initial condition not being in a list. But oh no, okay, I was wrong. It's more fundamental.
Yeah. Okay. All right.
That shouldn't fail.
Well, I understand. I mean, this is. I don't know why it's failing. I mean, could try a random other one. Oh, that's the causal graph, but that. So that should still work. If I run that now, that should still work. Beautiful. Okay. And then hypergraph plot of this should still work.
Yes, it should.
That's beautiful. And that's your new hypergraph there.
Oh, almost new.
Great. Okay, Jonathan, okay, so then what Jonathan will do, I will be out of multi-way system tomorrow. And so try to fix, and then in terms of examples, don't muddy up these examples too much. Put your own examples in there. Distinguish them in some way.
Okay.
Okay. If you have a chance to go through and just give examples of everything that's reasonable, do so. But
Sure.
Let's distinguish them, and they need in scope, they need all sorts of subcases and so on.
Sure.
All right. Magnificent.
Great.
Okay. Thanks a lot.
Talk to you tomorrow.
See ya.
Bye.
Bye. Okay. So I think then Max should go off and do his thing, it seems to me. And there's the question of building some registry stuff. And does Chris Parodi have design for the registry output?
I have not seen design for registry. Actually, he had shown me something for website, but he said he'll have them ready tomorrow.
Okay, but so when he's designing for the registry, he's going to give us a notebook that we can put a template notebook. Is that right?
No.
Okay, because that's what we need. Right? That's what we need. Somebody's got to convert whatever design he comes up with. It's got to be implementable in a template notebook.
Yeah, but yes.
Okay. By the way, I assume that if I did a rule plot.
Yes, it should work, but it might have scaling issues in this version. Okay, that actually worked.
Let's take a look at this guy. My God, what does it mean? Okay, until we have brains, we're not going to be able to see really what this means.
No, you can see there are two hyper edges because there are two regions. You see the two loops on the right are connected, so they're one edge.
Okay.
And this loop on the left is connected with the vertex, so it's the second edge.
Okay. This is going to look much nicer with brains, don't you think?
Yes, it will.
Okay. And then what we'll end up doing for the main illustrations is we'll use brains up to a certain size, and then we'll just drop the brains because you won't notice them.
Probably. I mean, I'm not sure we should do it automatically.
No, no, no. No, but in our code, we'll do that. Okay, so the one failure here, which kind of annoys me, is that Ed has not succeeded in improving on the enumeration code that I wrote, basically. Is that a true statement?
I think he's not gotten all the cases.
No, no, no. He hasn't gotten the one case that I specifically asked him to do. Okay? The one case, which was, you know, what I did here was I did it for the case of binary edges. This code here is a successful enumerator of the binary edge case. See what I'm saying?
Yeah.
So I asked him to do one thing 10 days ago, which was extend that to non-binary edges.
Yes.
He has not done that.
Yes. Because it seems it's more harder to do that.
Oh, bullshit. I just don't believe it. Do I really have to do it? I mean, come on. It's just not that hard. It may overgenerate in some cases, but then use the canonicalizer to reduce it. Sorry, I'm just, you know, it's just not that hard. I mean, look at how big this code is. This is just taking, you know, it's taking pairs, and it should take that partition comma 2 is probably comma n and things like this. Yeah, I'm sure that's n there. I'm sure if I replace that 2 with an n, I have a good chance of it working.
Well, I assume it's all the same.
I know, but I mean, if I just do it for
Right. I mean, I agree. It's especially if we have canonicalizer, it shouldn't be hard at all.
but I kind of really need this, like tomorrow without fail. Can we tell Ed that?
Yeah.
I need this without fail tomorrow.
Yep. Okay.
It's like super annoying because this is exactly what I want to work on now. So I can either just write this code myself, which means whatever Ed has done for 10 days is waste of time.
I'll talk to him.
It's really annoying. Really annoying. I need to send a mail about this. This is just stupid. It's just stupid. I mean, I asked him to do this one thing and he didn't do it. He's done a whole bunch of other things, but he hasn't done the one thing we asked him to do. Sigh. Total number of edges, distinct signatures. Okay. I'm sure that these 2's here are enough.
I mean, I think his point was, if I remember correctly, that it is just going to explode.
I don't care what his point is. I don't care. I just want the simple cases. That's all I need. Okay? That's all I need. I don't want to know that in some other case it's going to get bigger. I just need the simple cases.
Okay.
Right? I need the small cases. I need this piece of code generalized to arbitrary, arity edges. That's what I need. That's what I needed 10 days ago. And obviously I can do it myself. And I don't understand what this code does at all anymore. Okay, this min case is my simple canonicalizer.
Okay.
Right, so the whole point is that this is essentially needs to be a recursive algorithm which canonicalizes as it goes, but he doesn't need to do that. If he's incapable of doing that, don't do it, because I just need the simple cases.
Okay, yeah,
right?
That's fine.
But it will be good if he was able to do that, because it's obviously not very many lines of code here. may not be used. Oh, okay. So there it is. Let's hope that this is reasonably fast. Yeah, okay. Okay, well, I seem to have successfully canonicalized it here. At least to the extent that he's able to canonicalize it. See what I'm saying?
Yep.
Yeah.
Yep.
I should have just written this myself, then I would have had it 10 days ago. Okay, all right. I'm going to send out mail about this. This is just too silly. Okay, this is not a very nice note. There it goes. Really annoys me. I have told him many times, don't give me homework. Okay. All right. What else can we usefully achieve here?
I think we have a meeting tomorrow.
I know, I'm kind of disappointed because I wanted to look at these enumerations, which I now am not able to do because we don't have them. All right.
I mean, I do enumerations in my essay from the summer school. So the only issue is they might drop some cases which you don't want them to drop.
So you have code that might enumerate these things.
Yes. I mean, it's not industrial code by any means, so it might not work.
I understand. Well, let's look at that. Hold on.
By the way, speaking of priorities, what is more important, function repository or brains?
That's a tough call. How long is it going to take you to get brains done?
Probably a few days.
How long is it going to take for the function repository?
Hard to say, but probably the same. Depending on how easy it is. I don't completely understand how it works yet, so.
I know, I worry that what's going to happen with the function repository is you're going to start, then you're going to be waiting for other people.
Oh, I see.
Yeah, that's
Good
definitely
point.
going to happen.
So it seems to me you should start the function repository and see what the issues are, even though I'd really like to see the brains quickly.
Okay, I see.
Um, okay. Yeah, so I think you should start that. Okay, let's look. Did we already put something into the function, into the list for enumeration?
I think I remember seeing Wolfram model enumeration. I don't know if it was in my list or in that list.
I think we should have a thing called enumerate Wolfram model rules.
Yeah, there is Wolfram model enumeration that you listed.
That I listed, but we didn't put it in. Okay.
Yeah.
Okay. What is that doing? Okay. Okay. So you think you have something in the summer school for this?
Yes, which we just moved from results.
I remember. Okay, where do you think it is? Okay, well, let's take a look at what you've got here.
Yeah, so it doesn't canonicalize.
Well, we can always call the canonicalizer on it.
Right.
Okay, so let's put this in here. And by the way, you can tell Ed that he's expected to fill in a copy of this file. I don't want to see something where he's put it somewhere else. I want to see
Yeah.
it in this file set up so it's usable.
Yep.
Do you think that's all we need? So what are the parameters we give here? What's that?
Can you scroll down to see if there's anything else? Yeah, all systems also enumerates initial conditions.
I know, but that's not what we need. Okay, so how do we get?
So n here is the total length of, if you flatten the whole thing, n will be the total length of it.
Okay, but we want it by signature.
Well, it doesn't do that.
Okay, well, my code does do that, but it only does it for arity 2. That's the objective there. So if I were to run this, all rules of n, well, it's amusing, but it's right. Okay, so an alternative for what I could do is to say random Wolfram model rule, and where had I got to in the enumeration? Those are 3. Oh, I was doing, in fact, exactly that. Those are 2, 3, 4, 3. Okay, so there's a bunch of rules there. And then this safe hypermodel test button. So that's in fact what I would want to do there. And then that safe hypermodel thing comes from SWNet. Okay, so what aspects of this are not right anymore? Wolfram model.
By the way, why do you call it 7? There is already 7 there.
I just put 7 in.
It's all 7 dash rule signatures.
Oh, silly me.
This one should be 9.
Okay, thank you. Max, I really appreciate your attention to detail. And I don't say that at all sarcastically. No, it's great. That's how things don't spin out of control. Okay, so then here, that becomes hypergraph plot.
Yeah.
What do you think? Do you think these other ones look right? Let's try here. Drum roll. We got some big guys coming up there, I think. Well, none of those look very exciting. Now, what do you think when it aborted here? Do you think it aborted? Is there a way of drawing? Well, this hypergraph plot shouldn't be slow, right?
It's about 3 times slower than graph plot, as far as I remember.
Okay. You know what? I think
check.
that this now, the problem is that this is now got a time constraint that's actually working, whereas the time constraint before wasn't.
Well, I didn't change anything there.
I think on my machine, time constraint was just not working.
Okay.
All right, well, let's pick one of those. Okay, so there's the rule. Can you read these?
What do you mean? Well, more or less.
Okay, well, anyway, there's our rule. So now, okay, so that's starting with the all zeros thing. So let's see whether we can actually run. Let's see what it does. If I try and run this. Did I get that right? Why did it say generations count 0?
Because it didn't evolve.
Oh, that's because I have that the wrong way around. Okay, that looks civilized. Right, so what I'm trying to do here is 10 steps. So what I really want, let's go to 8 steps. Okay. That's uninspiring. What do you think the heck do you think?
Well, they're all still zeros. Because it never, okay, I see both, okay, first of all, there are no new vertices on the right-hand side, so they all stay zeros. And the
Oh,
reason it's slow is because vertex degrees are very large, so it's considering any possible subset.
okay. All right. So then,
Yes, it's quadratic in this case.
okay. So then, let's start making filters. Okay. So no new vertices. Q.
Yeah,
of-
that's easy to do. We could just do 2 pattern rules and check if there's module on the right-hand side.
Oh, that's a hack. Let's just do. So let's say LHS arrow RHS. And then we say,
Well, we can catenate both and check that, let's see.
we just have to union the catenation. But we can flatten these because we know we're going to use integers.
Be careful with union. Well, okay, in our case, it doesn't matter.
Okay, so the question is there something, a complement on the right-hand side? That's on the right-hand side, right? Is there anything on the right that's not on the left?
Yes. Can we use catenate instead of flatten, just in case?
You know, one would think you were a cat lover. Never mind, I'm sorry.
No, I encountered this bug before in hypergraph plot. That's why I remember.
Whoops. That's new vertices Q. Checks that. A much more modest number. Okay, let's try running this. Okay, are there any we care about here? You think that one guy might be interesting? I doubt it, but it might be.
Doesn't look like it.
I'm going to try anyway.
By the way, one problem with these notebooks is that they're very hard to rerun because you're using reference to kernel outputs.
I know, I hate that. I'm just sloppy.
So it's much better, I think, to use variables.
I'm aware. How could that be? What did I do wrong? That was that guy. Oh. That's wrong. Okay, what's happening here?
I think it's just a bunch of, it's center connected to a vertex with a self loop in it, and then just produced a whole bunch of them.
Right, it's like making a bunch of balloons. All right, so let's try here. What case should we try? So 2, 3. Well, let's just try more of those. Let's try 7, 3.
I think we should have more than 3.
Do you think any of these are going to do anything interesting? Let's see what
There are only
that
2
guy-
vertices in the rule inputs. I don't
What do you
think
think that
that's
one is doing?
enough.
What?
Which one?
This one here. Okay, what on earth is that? It looks extremely center connected. Any idea what that thing is doing? I don't think this is totally obviously trivial.
Can you do rule plot of it?
It's pretty trivial. It's doing some weird counting thing.
Well, obviously it's in counting. It's not
Let's look at
entirely
something.
obvious which one.
Let's look at something. Let's look at the states count.
By the way, is it okay if I drop off?
I'm sure. Yes, sure,
Okay.
yes.
Do
You're
you-
gonna miss the fun.
I know, but I also, Connor just burned my food, so I need to do something about it.
What?
Like, we didn't have dinner yet, and he was supposed to do dinner.
Oh, I see.
And
Yeah, okay.
there's just, yeah.
Okay. Fair enough. See you later.
Okay. Do you want to record?
Yeah,
by the
I'll
way?
record it. Yeah.
Okay.
Thanks. Okay.
Bye.
Bye.